Okay, guys, I'm going to do our last concept within the first area of study for chemistry. We're going to go through empirical formula. So empirical formula, let's just have a look at our notes just to make sure we're in the right point. Empirical formula is of any compound is the simplest whole number ratio. Okay, so we're looking for what is the ratio of one element to another element. An infinite lattice, such as an ionic compound, we only use empirical formula because you can't calculate exactly how many atoms of sodium there would be in a lattice of sodium chloride, magnesium oxide. It's just way too big a number. So we use the empirical formula for ionic compounds. For a molecular substance, which is what we're going on to next topic, when we talk about covalent substances and molecules, there are two different formulas. There's a molecular formula, and that'll give you your actual number of atoms. And then the empirical formula is our simplest whole number ratio. So what we're going to do is we're going to use the percentage composition that we just figured out to see if we can figure out what the empirical formula of different compounds is. Okay, so the first thing is there's a little table here that we can go through, and I'm just going to bring it back up on here. So you need to be able to do an experimental determination. We normally do quite a large practical based on this topic, but because we're a little bit restricted with not being able to be in school and you guys not being able to thermally decompose things at home, that's not very safe. We're just going to do this theoretically for now. If we get a chance to, when we come back, we'll make sure that you get to do the experimental determination. All right, so here are some examples of what we mean by molecular formula and empirical formula. So empirical formula is your simplest whole number ratio, and that's over here. You can see that hydrogen sulfide has got 2 hydrogens for every 1 sulfur atom. You can see here that, and that has the same molecular formula as empirical formula. With this second one here with butane, and we come back and do organic compounds, and butane will be one of those in the next topic. We talk about C4H10 is its molecular formula, but this is not its empirical formula. It's not its simplest whole number ratio. So when we do this, we'd end up with C2H5. So some of you might be able to see some patterns around this, some cheats. You might know how to do this in maths a bit easier, and you can use that. Please do use that to your maximum capacity. Glucose, you can see here, this is not its empirical formula because it's C6H12O6, and its simplest whole number ratio goes down to CH2O. So for every 1 carbon, 2 hydrogens to 1 oxygen, and that's our simplest empirical formula for that one. So how do we do it? The first thing we've got to do is we've got to measure the mass of each element in the compound, and then we've got to calculate the mole of that and calculate our simplest whole number from there. So let's just have a look at our first example. Oops, let's go this way. All right, so a hydrocarbon contains 85.6 carbon by mass, and this is the example that's in your book. What is the empirical formula of the compound? So the first thing we have to do is we have to identify what a hydrocarbon is. So a hydrocarbon is a compound that contains hydrogen, sorry, that's the wrong one, hydrogen and carbon only. I'm just going to put them down like this. All right, so there are our 2 elements. So the first thing we need to know is what are our 2 elements. So we're going to put them down. Carbon in ratio to hydrogen. Now, if it's 85.6% carbon, we can say that in every 100 grams, there would be 85.6 grams of carbon. If there are 85.6 grams of carbon, how many grams of hydrogen are we going to have? We're going to end up with 100 minus 85.6, which is going to give us 14.4 grams. So there are our 2 numbers, and I'm just going to kind of ignore this bit for now so that we don't get too bogged down in it. So here we have our mass. We always start off with our mass first. Now, the other thing we need to be able to do now is we need to be able to convert it into mole. Now, remember our formula for mole? Mole equals mass over MR. Okay, so we're going to divide it. Oh, sorry, that one should be over here. We're going to divide it. Oh, it's still the wrong one. Sorry, guys. Divide it by its mole. So by mole. So to do that, to get the mole, we're going to have to divide it by its mass. Now the mass of carbon is going to be 12. The mass of hydrogen is going to be 1. Where did I get these from? From the periodic table. That should give us a ratio. Okay, so our first ratio we're going to get is 7.13 ratio to 14.4. All right, now to make that the simplest, we divide by the lowest number. Okay, so we're going to do that using, where's one more color? There's red. Okay, so I'm going to divide that by the lowest number, which is 7.13. What we end up with is 7.13 divided by 7.13 should be 1. And that is approximately 2. Okay, so therefore, if we've got that, we can say that there's a ratio of 1 carbon to 2 hydrogen. If we write that out as the empirical formula, we get CH2. And that's our empirical formula of this hydrocarbon. I'm going to stop that one there, and then I'll do another video with another example.